Hi, welcome to this short video on how I like to teach the R method to my maths A-level students. In the textbook, in the Edexcel textbook, this is known as chapter 7.5, simplifying A cos x plus or minus B sin x. I'm not a huge fan of that as a title, so I like to call it the R method because most of the time these questions involve finding the letter R, not always though. Right, to begin with, you could offer this up as a starter, putting a question on the board for your students to try and solve. This is a past paper question. Every question that I do with my students is a past paper question, just to get them familiar with the layout and the difficulty. I give them a few minutes and then I'd ask them what is making this difficult and what would make it easier. So most of the time, they're more than welcome to try and solve it. Ways that they might do that could include squaring both sides, to use the AS identity, sine squared plus cos squared equals 1. They might divide through by cos theta, and then again they would also have to square both sides. And so it's worth at this stage mentioning the issues with squaring both sides of an equation, that being that it will often result in additional solutions. So if some of your students are super speedy and go ahead and solve this, I would ask them to plug their answers back in to check them. They should find that some of them are not going to balance the equation. And then I'd want to talk to them about which identities we can rule out using. So for example, I've just mentioned the AS sine squared plus cos squared equals 1 and the year 2 reciprocal identities aren't really appropriate because we haven't got any squareds in here already. So that's why that's a clue, especially as we don't want to be squaring both sides to introduce them. Secondly, the double angles identities aren't appropriate because of the angles we have here. They are the same. We've got a theta and a theta. I tell my students the only time to use the double angle identities is if you've got different angles, specifically doubles. So thetas and 2 thetas, 2 thetas and 4 thetas, and so on. So I always get them to look at the angles first. So we've got same angles and there's not an obvious identity to use. Next, we could introduce the aim and have a go at expressing the thing we were just looking at in the form r cos theta plus alpha. And then we always have these constraints, r positive, there will just be one alpha. So I'd go through with them how to do this, including giving them the steps for success. So first of all, we can write this out in full and expand it using your addition formula. You can do it in more steps with them than that. That was quite quick. So applying the addition formula to the right-hand side, I say expanding, as long as they know that to expand this is expanded with the formula. It's not expanded just by cos theta plus cos alpha, which you do see some students do. And then we are going to compare coefficients. Sometimes they can get a little bit mixed up, so I always get my students to tell me what they are comparing the coefficients of. So we're comparing the coefficients of cos theta, and we're comparing the coefficients of sine theta. And then you would never ever get a minus sign and a plus sign on different sides. The negatives will always cancel. So the -5, so I'm just going to write 5 because it's going to cancel with the minus r. Great, and then we can square, add and square root using the identity sine squared plus cos squared equals 1. Again, you can do this in a few more steps with them. And we get 13, positive 13, because R is positive. And then we can use the year 1 identity, sine over cos equals tan. So in this case, it will be tan alpha equals R's cancel, get 5 over 12. .6, and I would always recommend my students to store that value using the store button on your calculator so that they can retrieve it later on, emphasizing that they shouldn't really ever be using rounded values partway through a question. And then you do really want to invite them to write this out. It says express it in the form, so that's 13 cos great. And now we can go back to the starter, and which is also this question, and have a go at solving it again, this time using the hence in the question, and so therefore using your R method. So substituting in, solving this, and they will get the correct number of solutions, and maybe just seeing what they preferred and maybe asking them how would they recognize this is what to do next time. You can give them the list of steps. Something that I tell my students that have really got the hang of this and they're working quickly, sometimes I'll give them an even quicker way of doing this. It's not for everyone, but I'll mention it briefly. So an even quicker way is that you can skip most of these steps. You can especially skip step 1 of writing it all out, because all you really need to do ever is just square, add and square root these two numbers, the 12 and the 5. Doesn't matter that it's a -5, because you're going to square it, it will become positive. So I would have found this straight away by typing in my calculator 12 squared plus 5 squared square rooted, and I would have written down 13 immediately. And then this is where it gets a little bit more confusing. To find the alpha really quickly, you look at what's here, it's a cos. If it's a cos, you're going to do tan inverse of the sine coefficient divided by the cos coefficient, which is actually what I did when I wrote this out the long way. You do not take the minus sign. If this had said sine, then you would do the cos coefficient divided by the sine coefficient, and then take tan inverse of that. So that's a quick way of doing it. I find that my A star students like that because they'll take anything to speed things up, to give them more time on the really tricky questions. Great. Then you could give them some time, or you would want to give them some time to practice this. This one's really similar. Getting it in the form R cos again, so letting them practice that. I'm still in degrees. And then what about if it asks for it in the form R sine? So maybe giving them a moment to problem solve how that would be different. It's not actually much different. You just need to make sure you use the sine addition formula, and then when it comes to comparing coefficients, you might need to be a little bit more careful because, well, you'll see if you do it. My trick works here as well. So my trick for this one, the coefficient here's a 1, here's a √3, so all you would do is square those two numbers, add them up, square root them, that will give you R. This is a sine, so to find alpha we would do tan inverse of √3 over 1, the cos coefficient divided by the sine coefficient. And then I'd ask my students, so why is this useful? Why is this technique helpful? What type of question would it help us with? So we've already seen it would help us with solving because it gives the correct number of solutions, and it would also help with sketching. And with sketches comes finding maximums and mins as well. So those are several ways that this is useful. And when is it used? When do we spot it? So it's when we have a sine and a cos added together with the same angle. And that angle doesn't have to be a theta, it could be a 2 theta, but it would have to be the same angle. So then you could let them see an entire question carrying on with one of the ones they just practiced, where they've already found R and alpha. You could let them solve. So setting it equal to 7 here, it says hence, so there's a hint there to use their answer to part A. And then there's an example of what I was just speaking about. They have to find the minimum value and then solve for when the minimum occurs. And finally, there's a question that I think us teachers need to be aware of, which is June 18, paper 2, question 7. This question did not mention the R method. This is how it looked in the exam. So the students needed to know to use the R method themselves, whereas I'd say 99% of the time they are given it the question as write this out in the form. But here is an example when they didn't do that. And as you can see from the examiner's report, the most popular strategy was to square both sides using sine squared plus cos squared equals 1, and extra incorrect solutions were generated as a result, and only a few students rejected these extra solutions. So therefore, based on this, I would try and encourage my students to recognise when the R method can be used, and failing that, if at any point they square both sides of any equation, they should plug their answers back in at the end to check them. Thanks for watching this video. If there's another topic you'd like me to cover, please put it in the comments below.